and what remains. And the whole point of what we do as a designer is also to improve quality of life. So it designs people's life at the end of the day. And that's my vision. So as he described also, what I've been doing is also putting together a set of definitions or a strategy that, again, will allow me to be more practical, because it's very easy to just imagine, but when you are in this profession, you really need to take and bring to market some solutions. So there are big investments, big corporations do percentiles of the gross sales in the billions, and they're expecting a return. So in a way, the process deals with technical transformation and the application of structures, procedures, and the principles of the biological systems. And it's truly interdisciplinary, so I don't want to be staying here saying I'm saying we are, and this is one of the most important learnings of nature-inspired design. So just a short summary of the history of bringing biologists into the table. So if you go historically, and you have the first examples, from actually the early century in England for furniture design by William Morris. Then you have all these, incredible decorations in French furniture also from the early 20th century. And you go over for German works and, just more over the engineering and the science itself of engineering application. Then we have the influence in the 1920s from American industrial designers like Raymond Loewy and you name it. So all these particular informations were always taking part of that. But in the early 80s, there was actually a big influence on software. So the technology has evolved, interactions were different. Still, the model of learning from nature, neural networks, all the ideas in how body works, and I've seen several of you have actually expressed on that, it was actually a very important step. And it moved into interaction design after all these mathematical equations and fractals and so on have to be actually set up in a flat screen. And then all this evolution have making more and more than human factors, as a driver. And lately, business factors, of course, take care of that. And of course, the whole historical data. But at the end, there was some coin name by one of my colleagues, Janine Benjius, called Biomimicry, which is a very completely different, approach. I mean, I think biomimicry or biodesign at the end have the same trend setting. But in my particular work, I've been always trying to have truthful implications of how nature initiated. And then we go to a part of how to compare. So what is happening is, I will call it a standard design process, what you do is you take advantage of data that you have either accumulated or learned from, different experience. And it tends to be linear. And so one of the important things you learn from nature is that nothing is linear, nothing is perfect. In fact, the idea that whatever you see today happening is the best, well, it's not, because there is a 4.5 billion years behind to actually a snapshot of what you can see as perfect. So if you can take the same paradigm and put it lower, so the original comparison is how to integrate all the different elements that touch and influence the design and make it in a way, in a simple way, which is really the most hardest thing to do. So for us designers, it's all about the economy and the ecology of the product. For the mechanical and engineering part is material. So there are some classifications. So you can start from total mimicry, and as a definition, is an object or material chemical structure that is indistinguishable from the natural product. For example, any attendant flying machines that we saw at the beginning in Da Vinci's. A partial mimicry where you actually can go and put the natural as an example, the wood or any of these materials. Nanobiological analogies, as I say, I don't have to lecture anyone here. And then abstraction. And the last one is inspiration, which in a way for designers is actually the most, if you want, the most ideal, because the whole point, as I say before, is to create experiences. And they are, and they should be in a certain way more close to nature. So you can have inspiration. I say you can see it and you can have it. It's a part of your historical genetics. So in your DNA. So the learning of a child in terms of how physics work and what is gravity, you need to fall to stand up. And there's a whole process in how you learn and put it on. This is actually in your fabric. And you can see how the expressions of that, in this case, a person with a tail of a humper whale, and these lamps by Artemide. The idea, again, of keeping that going. So materials, one of the most interesting aspects. In nature, we have learned that it's not about pigmentation only, but it's also about layering and reflection and light. And so I have an incredible opportunity at Herman Miller to help define different areas in terms of fabrics designs, which again, the whole manufacturing process was important. But inspiration for materials, again, a big aspect of what we use as a database. Then, of course, colors without pigments. And, this is a classic example, the beetle, exoskeleton, reflections in light. And so the paint, similar effect that was used for the first box from Volkswagen. So, and in fact, then you have the analogy of the shape, that I don't know if it actually was truthfully that, but it's an interesting comparison. Color without pigment, as I say, this is actually the sea mouse. It's a worm that live underwater in certain tropic areas. But what is interesting is it actually reflects the lights. As you probably know, when you go down, the spectrum change, but this animal is capable to actually absorb and transform these colors. And in reality, when you go to the microscope, it's just silica and natural material that have the possibility to reflect in different ways. Very interesting as a model. Burmistone Fuller's and his inspirations, based on water insects and other structure or tensor structure was also part of the big architectural investment and development for new ideas. And of course, I've seen some robots here. I was close to the UC Berkeley lab when I was at Motorola, actually, in this locomotion machine from Polypedal Laboratory, which you may be familiar. The interesting part is, the speed and the capability of these animals with, by just repeating and modulating the same movement, constant. So it's about simplicity, it's about economy. That's really the most important part. Adhesion, I'm sorry. So the idea of the goosegrass and Velcro, very old concept. I guess all of us know, very simple in terms of implementation. So it's the stress of materials, the stress of the technology, but it's really about how to define at the end the implementation. Adhesion, in this case, the gecko. I have a very incredible opportunity to work in DuPont with this, for developing different fabrics and materials. And then, finally, there's some companies that have developed this particular, for healthcare, sleep apnea mask in the United States. Of course, fluidodynamic and aerodynamic. Some pumps. Pack Scientific is an Australian company that have been actually capturing and capitalizing on analyzing all the spirals from several, shells, and then portraying that actually in concept and products for turbines, water turbines. So why this is exciting for us, for designers? And I will define designers as, a large word. So anyone who is creative and wants to do something new. Well, first and foremost, nature give you not only the inspiration, but as I say before, the balance between sustainability and the design solution. And, as usual, is appropriate, elegant, and simple. And this is one of the examples of my first work, which I'm going to go in detail sooner. It was the design of a very simple tool. It was a hammer. It was an ice axe that was actually based in the woodpecker capability of penetration of wood. So what I define as a process, as I say, taking in consideration the linearity of the standard product development, the idea was to actually overlap into this process as many as possible implications from nature in a short term. So in average, what we actually, and I've been capable with my team to do, is to simplify at a fourth or fifth the time of development for new ideas. And this is really where the opportunity for IP and innovation is, where nature has been actually a very good tool for my process. So the idea is overlap the standard one, as I put there in green, and then, as I say, have as many inputs. I just showed 3 here in every of the phases. So the simplification and the integration of this knowledge in every step will help deploy the process. So there's no time frame of losing or experimenting, but just implementing right away. So in that case, as I say, in my process, you go for observation, for identification of the principles. I mean, and it's really about the principles in physics, mathematics, and so on that will allow an implementation that is capable to be productive from the standpoint of manufacturing. And of course, evaluation, as you probably know, is very interesting not only to conceive, but to test with real people, as I said at the beginning. So the delivery time, as I say, is a shrink, normally in average a quarter of the total time, and this is what, have been a success, at least from my process in big corporations. So the other thing I do normally is just to integrate 3 of them together. As I say, nature is about, simplicity of complexity, or expressing in a simple way that. So I have 3 themes: bionics, understanding that as a concept from nature and shapes; the fractal, the mathematic, the aspect that is, that make the feasibility a reality. And then I call this a technical romance, so you need to make it. You need to produce it. And you need to produce it within a budget. So this is one of the other things that normally we forget. So with all that, the idea is to being capable to create beautiful things that are very aggressive and, opportunities. So as I say, the approach is defined here, and I'm going to then start showing some examples of my work more in detail. So let's start with the woodpecker. So at the time, this company, whose Camp, was an Italian company. It is an Italian company that was celebrating 100 years in the early 90s. They wanted to actually come with something completely different, completely new. You need to understand that also 27 years ago, the whole idea of mimicking nature and doing something was very, very hard. And we actually came to the biologists. We have the possibility. I was actually working in Milano, and there was the head of the Museum of Science who actually gave us, several ideas in how to resolve the problem. So what is the problem? You are climbing in ice. You actually, ice change physical properties by 1 degree, and then it can be as brittle or as hard as you, can imagine. So which animals in nature do actually have a solution for high penetration with the minimum effort? So we went to the woodpecker. As you can see, of course, the whole idea of this body is not only to give the capability to the animal to use the tail as a spring-loaded, mechanism, but also the variation of angles so that can increase. So these animals are probably about 35 centimeters long. The head is probably about 2.5 centimeters. The back is probably, 1 centimeter. They can actually do hits of 25 times per second against the wood. And they don't get crazy, don't get, destroyed. They create a pneumatic system in the brain, to actually contain the impact. But the most beautiful part here is actually we use all of those elements to redefine that tool there, which I have a sample here that it was very hard to find, which, what I need to express mostly here is this tool has 7 patents of invention in a hammer. And so, again, from the standpoint of quality and innovation, nature is actually the best example to follow. This tool actually is in permanent exhibit in the museum in Denmark, Museum of Design in Copenhagen. And again, I have it. I'm going to put it there as you want for display. Aside of that, working at DuPont, we developed several new materials. There is also a shark texture, based on the skin. And, the most important was also the mechanism that allow with a single screw to variate angles, same way that we actually look at the bird. But the most important, most interesting is it works. This is Pierre Tardibel. He's a famous climber, extreme climber. This is the northeast wall of Mont Blanc, I'm sorry. And what he does is he climbs, and then he falls down in skis. He's really crazy, but he's using my tools. This actually is from a, New York Times magazine. So, ice axe, woodpecker. So then we move into Motorola. So Motorola, the idea of implementation of this particular knowledge was actually aimed toward the concept of connectivity. Now, connectivity in different levels. As many of you know, my years at Motorola were from the 90s until 2004. where the possibilities were really, really immense in terms of changing, how things were done. And we have this opportunity to truly reinvent everything. You probably know the razor and all these products came really from extreme push of boundaries in terms of innovation. So we have a product that we were doing for the government. It was a technology that needed to actually understand and be in water environments, submerged. So we created this line of products that literally have a two-way radio and internet, and this is actually 2001. But it needed to be submerged for at least 6 feet underwater, 2 meters, for more than 24 hours. And so our inspiration came from understanding and analyzing crustaceans, the exoskeletons. So we work with BSF, and we work also with a company called Cambridge Electronics to develop a specific and a special material that has actually a co-injected magnetic element, particles inside the fiber, the resin. And then with that, we were able actually to create in a single layer, of 1.5 millimeters, a very highly connectivity material, kind of like the same way the fabrics in your body are. And this product then, has center flexibility. Again, as you can imagine, this was a clamp. For many of you that remember the early phones, you needed to open it up, have the antenna. All the pieces were actually made in one single shot. And the product, became one of the most highly productive. We produce of every of these single phones close to about 20 millions in a range of about 5.5 years. This picture on the left is from our main lobsters. And actually, this product is actually today in permanent exhibit also in the museum in Motorola in the United States. Then I have an immense opportunity of working with a car company. I work in Pininfarina in the late 2000s. And the opportunity was, how can you define a new car which take advantage of all the different connectivities in a city? So it was actually a very complex work. As today, you probably know, there is several efforts from Google, from autonomous cars and so on. But the reality is that you need to have different pieces in the ecosystem for this to work. But they need also an example that can help you understand how to implement it in a rational way. So we went to study ecosystems in the water. We went to study the sharks again, but from the neurological and also actually sensorial side. And we discovered that several of the ideas, and I saw yesterday the work from the German colleague here on the fishes. So the whole point of having an individual in an ecosystem to communicate relies primarily in what you do with that communication and how that communication can imply some benefit to the others. So with technologies, we were capable to understand, for example, how to evaluate and help for the security of the car. In the cities, what happened when cars will be in a certain speed, and also there are so many of them, and the people and so on. So this car, this Birdcage Maserati, we were able to integrate, this is in the year 2003, about 250 technologies that include proximity sensors, include also infrared, head-on display. If you can probably see in the part of the display here, it was a projection. And the other interesting part, it was a fly-by-wire car. We did only one, but it resulted as an inspiration for the Maserati line. This car actually is still is a working car. It's in the museum here in Torino, in Pininfarina. But as I say, we were capable to move these technologies then in different products. Then from the spin-off of this car came several opportunities for what we call wearables, which is a coin name that I think should be more defined as a data gathering, devices. Wearables technologies that will allow you to capture and transmit this data. So we have the opportunity, several of us, probably about 25, to actually create a new company, as Tony described before. It's called Vision Mobile, or VSM Mobile. We funded this a year ago. And the concept for us was to actually take some of this knowledge and create inspiration from computers. So as you probably know, Silicon Valley in the United States, we have Jeff Hawkins and others, that actually Jeff Hawkins and Vint Cerf, who have been pioneers in that level. And so we are trying to take advantage of the single cell neural network and having described, pieces that can be truly being warm, unobtrusive. So on the right side, we created this button, which I have one sample here. This is a coin, probably I would say an euro in diameter, about 4 millimeters in thickness. We have 4 sensors right now, 5-axis accelerometer, a GPS, and a Bluetooth. But the intention for us is to grow that and put several other sensors that will help us into the healthcare environment. So the idea again is just to substitute and suffice the needs. And this chart again is mostly a representation of what happened in this idea of integrating natural input. So you first have to actually give benefit to what you really need in terms of the human is to eat, to rest, to be healthy, feel secure, and communicate. And then extrapolate all that with all the different options. So a roadmap at this point start with, as I say, a single button, but we're moving that into the body, with other sensors in the next 2-3 years, which actually include environmental sensors like the camera in the top, which we launched also last week. So the idea of that camera is actually the size of a can of Red Bull. Is to capture in 360 all the information. It can be monitored through your body using the button that I show you, and all the communication, the pipe, is actually through the cell phone. So it's very unobtrusive. You're talking pieces that you cannot, really contain in your hand, but the multifunctionality is very intriguing. And so, of course, you can have that application in different areas for home, public safety, and so on. So that's some of the products that we are doing right now. So as a primary conclusion, what I think is important is how nature can be used, and as I say, I've been using for the last year in terms of help as a database. So the list is enormous, but I just picked several of those. So sensors, based primarily, in any of the different pieces or extremities of animals, mechanical design, structures, fluid dynamic, and again, the list is long. But what I'm trying to represent here is that it is actually most efficient just to understand how nature have resolved it and translated, because at the end, what you're looking, again, as a professional, is just to put that in the market to test and to sell in short time. So this is a short list of what I consider important as a conclusive statement. It's a tool, definitely to influence concept process, stimulate creativity. So it's a very, very high effort, to try to be innovative, and I think nature is helping in that way. Contributing for all the disciplines, as I say, there's no I. It is truly reality, and as nature actually represent, and expand the knowledge for barriers. And I conclude with an interesting quote from Ben Franklin, tell me and I'll forget, show me and I might remember, involve me and I'll understand. So thank you very much.
Thank you very much, Franco. So time for a few questions. So we'll start here.
Thank you. Interesting. Interesting perspective on all this stuff, at least for scientists, I'd say. For VSN, in terms of VSN's roadmap for the next few years, it looks like it's doubling down on sensor, more data collection, more ways of collecting data, less obtrusive sensors for doing that. Do you have any plans or any partnerships in place for analyzing that kind of data? Because the utility of the data, obviously, to impact what you're talking about of making a better quality of life, better experience for the user, is determined by what that data means.
Yes. Totally, yes, yes, good question. We have different partnerships with large networks in United States and in Canada and Mexico. As you probably know, data is nothing without, knowledge. So the point is we are trying to gather this data to enable services through networks. And, we have the capability, being in a 4G environment in the United States, of truly push that opportunity, in how to service. Healthcare is one of the big areas that everyone is touching. We are planning to have multisensorial, devices that will use, as I say, the cell phone and their services to move forward. So we have also, because the business model for us is you have quarters. So you have to, in 2-3 quarters, demonstrate that it's really capable or else, and move it out. But yes, it's how to implement the data for a specific application, short term, to actually create more value in a faster way.
Well, first of all, thank you very much for such an inspirational talk, and I can only congratulate you on your achievement. This is really fantastic.
Thank you.
What I would like to understand, because I'm not a robotics person and so on, and I'm not into this field, but what I would like to understand, since we are trying to create a center of biomimetics in Edinburgh, what is the mechanism or the thought process that goes with this? In other words, do you have first an objective, a problem that you want to solve, and then you look for inspiration in nature? Or sometimes it just happens the other way around, in which you see something in nature that you can imagine that then goes into some interesting technological application?
Mm-hmm. Yes. When you do it from the corporate level, and I'm going to talk with my experience, a large corporation will also press you as a creative to try to identify solutions for a real problem. However, in the process, we have certain database that come, serendipity. They come out because you learn it and you try to imply or use that into a reality. The point is, to have a clear idea of why this particular knowledge is created. And it is created to develop and create more innovation in the process or in the final product. So it's a balance between both of them. Normally, I've been, in teams where we report at a C level, so either CEOs or chief marketing, because it's the best way, as I say, to deliver the message is to having, the marketing, information on time. It is, I just want to say it's not simple, but what is interesting is people is looking for so many new ways to be innovative and creative that it's right now a time, where you can do definitely a good impact. So I think.
So Franco,
please.
I'm here.
Oh, I'm sorry.
No worries. You can look there if you want. No, but so this is fantastic, right? So you take different biological systems on the basis of which you then design a product, right? But on the one hand, there's a risk it becomes fairly ad hoc, right? So my question to you is, now across these different products you have designed in this way, do you see principles emerging where you say, well, yes, actually, whether I look at a shark or at this woodpecker, there are generic principles that yes, I can now start to generalize to a more, let's say, a generic design process? Yes,
definitely yes. I think I can enumerate 3, by heart. I think the most important is, the transferring of the base data. So the first principle is, curiosity. So exploration. Exploration in any level, material, structure, shapes, forms. Second one, I would say, and more important, is integration of knowledge. Because as I said before, I can come out, as a designer with interesting shapes, but they may be not feasible, structurally or mechanically. And so the whole idea of become the voice, for the team to actually portray it and push in that side. And then there is the other part that is manufacturing. So in many cases, whatever you see in nature is impossible to do at the moment with the knowledge of that technology. But it helped push the boundaries to open the doors, you know, to invent or reinvent either the process of the material.
But so you're describing sort of the process that you're in as a designer,
Yes,
right?
yes.
But I was asking you for something else, which is if you now look at these biological systems,
Yes,
if you compare your woodpecker with your shark and your lobster,
yes.
do you see common principles emerging
Yes,
in those
simplicity,
systems?
expression at the end is simplicity. Yes, you're right. And that's why I bought, you know, I brought this one here. Because the point of create at the end a tool that has to be used in a certain way without no high tech or coming to something like this, at the end is about the expression of simplicity. Yes.
Okay, I think we should stop there. So Franco will be on the panel for the discussion at the end of the day, and when I think one of the things we'll talk about is how, you know, ideas from science can make their way into design. But this is a really inspirational talk, I think, for us scientists to think about how we can bring our ideas to a much wider audience.
Perfect.
So we're now going to have the demos. Just before I did that, I wanted to just
Yes.
point out the design that's on the screen. Oh, sorry.
Thank you.